Hi, I'm Omkar, and this is the Night Agent, an autonomous production incident response system built to handle production issues while engineers are away. So, like in production, failures usually happen at the worst time, late nights, weekends, or when no one is actively monitoring logs. Alerts are noisy, root cause analysis is slow, and fixing issues still requires manual effort. So, like I will like to take one, you can say one catastrophe we faced just very recently, like when the Cloudflare service was down. It was affected globally and it affected us too. So, like the issue was very minute, you can say. One of our APIs from our Spring Boot Java server required IP addresses, and on front end we were using some other third party service which also got affected due to the Cloudflare, and it affected us eventually. So this thing would have simply, you can say, got fixed with the removing validation error for the IP address field. But the thing was, we were not around the system, and it and that resulted into a application being, basically you can see API being down for around 2 hours until the Cloudflare service got up. So so I thought, why don't I make a solution for it? So yeah, so the night agent acts like, you can say, night shift SRE powered by AI. It monitors production logs, detects real anomalies, analyzes the root cause, and even proposes fixed all automatically. So like how it works, the you can say, there is, you can see, if you can see in the screen. So what it does is, like, we have one sidecar agent that runs next to, you can say, your application, and watches logs in a real time. And when it detects something and when it detects something so yeah, when it detects something unusual, it sends back those anomalies to our backend server, and it backend server. So from there we are using Kestra orchestrator. There we have three main agents, can say a pipeline, where once we have anomalies from our sidecar agent, we are basically like validating whether what all anomalies we have received are worth reporting to the, you can say, client or engineer. So we have design like we are like I have created one prompt that flags all the anomalies based on, you can say, a high, medium, low priority, and one which has to be discarded, which you can say could be more are going to be most of the time false positive. As like we are for the sidecar agent, we are using anomaly detector, which is purely works on the basis of, you can say, statistical deviations. And another layer is with the, you can say, machine learning algorithm. So for it to get trained, it has to have 100 to 200 lines first. Then based on that, it detects the patterns. It starts detecting the anomalies. Most of the time, there are cases where we get false positives on our backend server, and that is why we have instilled one validator agent. Then there is, mm, once so Kestra what Kestra orchestrator does is, it can say triggers one, you can say, job where it sees all the anomalies detected in the DB, and validates all those with the agent. Once uh, once validation is done, then it is, you can say, another agent is triggered, which is analysis agent. And this agent, you can say, does an RCA for us. So basically what it does is, based on the anomaly detector, it goes and sees the code base, looks where could be the origin of that particular issue, and reports client back, or you can say application user, with what could be the issue and the origin of the, can say, it basically brings the snippet of the code where issue might lie. Then then there is, you can say, also it shows us the you can say shows us the fix, what possible fix there could be. So it just proposes a fix. And then there is the third agent, which applies the fixes which were proposed by the first agent. So in between these stages, you can say, we have kept the human in loop. So once the validator agent validates all the once validator agent validates all the anomalies, we are flagging those anomalies based on the, you can say, priority. As per the priority, analysis agent picks up all the anomalies, creates an RCA for them. Once the RCA is created, it gets back to us with the proposed fix. And when it gets back to us with the proposed fix, we are, you can say, basically seeing what fix is proposing. And also we can tell the analysis agent with the natural language to, if he has if the agent has hallucinated, we can talk back to the agent by guiding it. Then it again goes back to the right source, and again comes back with the proposed fix. Then the once like then we have kept once the proposed fix is approved by the agent, we are basically applying that fix on, you can say, another branch. So this apply fix agent is basically responsible for making the changes, applying the patch which applying the patch proposed by the analysis agent. So it basically creates the patch on new branch, which is freshly created on the master branch. And then it again comes back to the front end, showing the changes. And finally it can confirm and merge those changes. And so yeah, so I would like to show you how it looks. So basically, this is, you can say, very heavy application to work on. So most of the things are not working as of now. So basically, this is, you can say, I've created a mock case where we have injected one anomaly in the database, and our proposed fix agent has created an RCA. And here you can say I have approved the fix. Now it's showing me what all changes it has done to particular branch. And finally we can make changes, and we can merge these changes. So if you want to see, I can show you. So we have basically what we are, so I'll just explain you the architecture. Basically, we are making use of Git here only. can see, yeah, basically making use of Git for all the things. We are assuming that the code base is uploaded on some Git server or any Git provider. So I'm making use of standard Git operations. So during the onboarding, I'll just show you the onboarding flow. To create a new account, so I'm just creating a dummy account here. So there are two modes. So basically what we are here doing is we are asking user to share their Git repo, and we are recommending the SSH protocol. So most probably the Git repository is going to be private repository. So I'll do one thing, I'll just log into some other repository. So yeah, we are in. So what I'm going to do is I'm going to this is again creator. Okay, yeah, this is private. I'm going to add this. Here, so what it basically is doing is when I press on generate identity, it basically creates a key pair. Okay, and so yeah, so basically what it's supposed to do is it creates a key pair and gives the public key back to the user, so it can add the public key in their repository in their git store, so that we can have access to the repository. Once it's done, so yeah, we are in. So yeah, there are a lot of things which are failing as of now. So but yeah, this is the use case. I'm going to work on it, and most of the things are not working as of now. Like there are the sidecar agent. I've been so I'm going to package the sidecar agent in container, in Docker container. So basically, the Docker, this is going to be just a simple Docker image that is going to be run on the application server, which will ask user to just provide the path for the log file. And yeah, once it's up and running, it is good to go. Then there is the second pass, which is for the backend server. So I'm facing challenges with the you can say Kestra workflow. this K-Star workflow is sometimes failing due to the authorization thing. I had figured it out, but somehow it's again started failing. So this is one thing. So basically, like it's uh, if I dive in a little, I can will be able to make it work. But so this is it. What I have can say what I have made till now. So yeah, thank you.